Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get you started with Class 12, applying the logarithm transformation to your data for your project. So we'll go down to the timetable, we'll page down to Class 12. There is no RMD file here, which means that the assignment is in your project. So I'll go over to RStudio and we'll open up from, I have to get the right folder, my classwork folder. We'll open up the latest assignment, the RMD file, and we'll do two things right away. Okay, we're already down here at class 12, that's nice. Until I moved it, resized it. Alright, so two things we'll do is first we will save this as a new file name to reflect the new day. That way I don't break something from previous work. I will set the working directory to the source file. That way I can work on the work right here. I'll also knit it to make sure that the file knits. And with all that preparation, I guess I'll do one more thing. If I had something in my environment, I will click the broom and clear all the objects. And I'll wait until the markdown file finishes, and then I'll do that. And that way I've prepared my environment for work. All right, for today's assignment, we can start reading the rubric. There are two primary parts of the rubric. The first part is to try plotting your data on a logarithmic scale. So we're going to make 4 plots. The first is on the original scales. So basically go up to your previous scatter plot that you've made and then see if any of these transformations improve that plot. All right, we'll just go back to RStudio. Okay, so we're going to make those 4 plots. As you'll recall from the video for class 11, the separate worksheet for the logarithmic transformation, we made a little grid of plots which did exactly this. Okay, so that's the first part. Just plot them and label their axes. Number 2, what happened to your data when you transformed it? So now your goal is to interpret the plots from part 1. Notice you get 6 points. Most of the points is just creating the plots. That's pretty generous. What happened to your data when you transformed it? Describe what happened to the relationship after each log transformation. Okay, so we're going to use the original scale as the baseline, and then say whether we got more linear or more curved for each of the other 3 sets of plots. Choose the best scale for a linear relationship and explain why. And finally, does your relationship benefit from a logarithmic transformation? Okay, and in terms of does it benefit, does it improve in terms of linearity? Okay, so those are our 2 goals. We've got places for each of those down here. In fact, I've already, number 1, here's all the plotting will be put under here, and then here are the 3 questions. So I've got the whole framework for you, just a matter of going and getting the code and dropping it in. So we are, just to remember, we're a little bit before line 1400, sort of how I'll remember it. 1380-ish. So let's start by probably what I want to do is I ran the code, and here is the output. So I knitted it. Let's take a look at our original scatterplot matrix. So under graphing and tabulating, I've got plotting bivariate numeric response scatterplot. That's what I want. Section 541. And let's just see where we're starting, because maybe we want to continue with this, or maybe we want to try something different. So here is my plot. I'm going to make this a little bigger. It won't jump around. It always jumps around when you change size. So we've got age on the horizontal and total cigarettes smoked on the vertical axis. Now clearly the y-axis here has a bunch of clumping close to 0 and then is spread out. So I think this relationship could possibly benefit by a logarithmic transformation on the y-axis. Probably not on the x-axis. Yeah, so that's my prediction right now. Let's scroll down and see. There, of course, was the height versus weight relationship. I think this one's probably not going to benefit from either one. If anything, it could benefit a little bit from weight, since there's some right skewness in weight. But I think you would produce actually left skewness if you took the log of weight. And that's it. So that's all I've looked at so far. Now if I go up to the top for a moment and find the code book. There it is. I might, if I was in your shoes and this was my project, I might take a little more time to look at some other numeric variables. Let's see, the numeric variables that I have are daily cigarettes smoked, which I think I combined with smoking frequency to get total cigarettes per month. In terms of other numeric variable, I've got personal income. Income often is right skewed. A logarithmic transformation might be useful for income. And those are all the variables that came with the data set. We have days smoked. I'm guessing that that's not going to be very useful, probably mostly because lots of people are going to be smoking every day. Logarithmic transformation is most helpful when you have right skewed data. Lots of low values and just a few really large values. Total cigarettes smoked, okay, that's the one that we're already plotting. Smoking frequency, these are not numeric. Okay, so the only other variable I could think of to add in here is the income variable, income personal. All right, so I'm going to copy that variable name, and I'm going to insert a code chunk, Control-Alt-I, just like this. And I'm going to just paste this variable name in here. I'm going to comment it just as a way to remind myself that here's just something that I can look at. Weird, switching. Okay, let's go find that scatterplot matrix again. Or not scatterplot matrix, just scatterplot. And let's start with this plot right here, age versus cigarettes smoked. Okay, so I'm going to grab the code for this. This is exactly what I did for the other assignment last week, or earlier this week. And paste it in here. And I'm filtering it for total cigarettes smoked is greater than 0. And the rest of this looks good. So the one challenge here is I'm going to be doing the logarithmic transformation. I don't have to interpret any slopes. So the easiest way to plot and interpret the relationships is to scale the axis rather than create a new variable. So for this assignment, I'm going to propose, as we did in the previous class, you'll recall that I had a comment down here that we can use this code to scale the axes to a log scale. I'm going to copy this, Control-C, go over here, and I'm going to paste this up here as a reminder and put it in a comment. Okay, so I've got that code available to me when I'm ready. All right, so this is, I think I have all the pieces I need. Recall, let's see, let's remove anything that we don't need. So I'm going to remove the jittered points and the geom smooth there. We want just the stat smooth, LM, which will give us a straight line, and I've just removed the color. We don't need the caption anymore, and let's have some titles here. There's age, and I will also say, I think what I'll do with the title is I'll put the scaling in there, original scale. Okay, and geom point, we do have lots of points. I think reducing the opacity to 1/10, alpha equals 1/10, I think is pretty good. All right, so let's produce this plot real quick. I highlighted it and pressed Control Enter, and it didn't work. Do you know why? Let's see if we can interpret the error. Oh, there's lots of errors here. So, interesting. Not even the library ggplot seemed to work, or maybe it is okay. It just says where we can get more help. Okay, ggplot. So it has trouble in NESARC. This could not find this function. Okay, so I have not run all the code above this code chunk. So my environment is empty. I also have not loaded the tidyverse, which would make this pipe function available. So I'm going to now run all the code from the top. Come on, scroll down. Okay, it's loading the data. There it goes. Okay, it's going to get slow down a little bit on some of these plots, and then I'll be able to run this code chunk. I like making mistakes during the video because these are the types of things that you're going to run into also. And we'll just walk through them together. All right. In the other video, while this is still going, recall that we had a plot 1 for the original scale, and then plots 2, 3, and 4 for the other scales. And we'll do the same thing here. And we'll make a little 4x4 grid the way we did previously as well. All right, so this is still running. While this is finishing up, let's go grab in the last year's assignment. Also, you can look here because the new code will be updated here. But I'm going to go to last year, and I'm going to search for the word grid. Give it a moment to finish loading. Okay, and this grid extra, grid arrange, this is what I want, to be able to plot multiple plots together. Okay, put this back into RStudio, and I'll paste this down here. This is where I'll eventually put all these together. Okay, I won't worry about it right now. I think all the code finished. All right, we're ready to go. I'm going to press Control L. You can also click this little broom, and that clears the console. So now there's nothing in here except what I'm working on now. All right, so we've got this chunk of code. This is going to produce one plot. It takes a little while because there's 43,000 points, and they're all just showing up here. I'm going to reduce the opacity even a little bit more. Okay, that's not an important detail. Let's go and start scaling the other axes. So I'm going to copy this plot. Okay, that looks pretty good. I don't know, those light points look a little too light now. I'm not going to worry about it too much. I can go back. All right, so my second plot, P2, let's do a log of the x-axis. Log x. Okay, and I'm not going to think too hard about what I'm scaling right now. I'm just going to drop in the code to do it. Okay, I'm logging the x-axis, and so I'm logging the x-axis here. All right, let's run this and see that our plot changes. Okay, the x-axis along age looks quite different. It's really spread out on the left-hand side and or crunched in the upper bound. That is about right for a logarithm. We already had not quite a symmetric distribution, but it was just a little bit right skewed. A logarithm in this case turned that into a left skewed distribution. All right, let's copy this again. Now we've got P3. And we're going to do the log of y. And I'm going to change the letter x here to the letter y. Let's take a look at when we log the y-axis with a normal age, with a normal x-axis. Okay, that definitely made a big difference. Much more drastic than I was expecting. So now we have actually a left skewed distribution. It's sort of a clump of points above with a long left tail, is looking at the vertical axis. Okay, and of course, for completion of the assignment, let's log both axes, which I think is not going to be a good choice for this data. So we've got log x and log y. So we need another line here where we log x. And that's the fourth plot. We'll take a look in this little tiny window. I don't know, that's actually, I don't know, none of these are very good, honestly. But this is not terrible. You know, the density of the points follow the line not too bad up here. You can see how the regression line is a bit low, and that's because of the influence of all these points down low, which are pulling the line down. Otherwise, you'd want it to be a little bit higher through the darker part of the plot. All right, so I feel pretty good about having done the first part of the assignment. Let's put all these parts of the plot together using the grid extra. So we've got plots P1, P2, P3, P4. We'll do 2 rows, and I'm not going to bother having let's put a title, why not? What was the title of the original plot? Let's go back to here we go. Total cigarettes smoked versus age. So what we'll do, we will, did it jump up? In the grid arrange function, I will update the top argument, which is a title on the top, to have that total cigarettes smoked versus age. And the last thing is, we don't want all the individual plots to print, so I'm going to comment out all the print P4, P3, P2, P1. Okay, that looks pretty good. And the last part for thinking ahead when we're going to knit this, we want to resize this box to be a bit larger since we're fitting in 4 plots. So let's see where we can find that. Probably at the very top, the first code chunk. I'm paging down. Here we go. Figure height and figure width. I'm going to copy that piece of code and put it in this code chunk, and let's give it at least 8 inches, both vertical and horizontal. All right. I recognize I'm doing a lot pretty quickly, and the reason I'm doing that is I know that you can pause it and go back a little bit, and also we've started to see a lot of these individual pieces before, and so I do want to move a little bit faster. All right, let's zoom in this plot and see what we get. The next step we'll do is we'll knit this. Now this plot's taking a little while, and that's because we've got 43,000 points 4 times. So it takes a long time to put all those points down. I am so pleased. This is really nice. Total cigarettes smoked versus age. That's the top argument for the grid plot. We've got the titles. It's really easy to see what we're looking at. And because they're all together, it's really easy to make comparisons. Looks to me like, so from the original scale, we have a lot of right skew. From logging age doesn't seem to really improve anything. We're shifting the values to the left, but that's not really helping. When we go down to log y, this I think looks better than this first one. We have the clump of points is closer to the line, whereas down here there was a lot of density down below. And then if we log both of them, in my case, I don't really see this as really benefiting us that much more. So, but I think in my case, log y or log x and log y, either of those seem okay. So if you produce a similar plot, I think you're going to have a nice way of making some comparisons. You know what? For some reason, I'm feeling fiddly about this. Theme BW. This is such a waste of time. This is the sort of thing that you do when you start coding. I wanted the backgrounds for all these to be white, which will help a little bit seeing where those really light gray points are. So that's sort of my justification for doing this. Let's finish this, and then we will knit it, and then we'll look at the knitted version in order to interpret the questions in part 2. So I'm going to scroll down now to part 2, and let's think about what we saw. So what happened to your data when you transformed it? Describe what happened to the relationship after each log transformation. So comparing it to the original scale. Okay, so I'll sort of like put 4 versions in there. Original, okay? I'll just say same. Okay, then we'll do log x, log y, and log x and log y. So I would say no improvement when we logged x. Age values became left skewed. For log y, no improvement. That's what I meant to say. Some improvement. This was cigarettes smoked. Cigs smoked became left skewed, but the regression line was closer to the center of the data. And I would say that's pretty similar for log y as well. Sometimes you're going to do log x, log y, and that like totally fixes everything. It's so beautiful when that situation occurs. I believe I have a section, I have an example in the lecture notes about, yikes, was it like species abundance or body size or something like that? It's an ecological example where log takes a plot where you have like a real L shape of data, and log x or log y doesn't quite fix it. But if you do log x and log y, then everything looks beautiful. All right, some improvement. Sig smoke became left skewed, but regression line was closer to the center of data. Age transformation doesn't help. Okay, choose the best scale. I would say let's go over to here and refresh this and find the current assignment. statistical methods, log transformation. All right. Do we have our plot here? Yeah. All right. Let me zoom out. So which one is best? Now, a reality of the data that we're looking at is that log transformation may not actually fix anything perfectly. This is the nature of this type of data. In real research, we may decide not to use linear regression for this type of relationship. There's other types of relationships, such as or models like quantile regression, or we might choose to do something a non-parametric type of model. You know, things can get pretty complicated once they start not fitting our model assumptions very well. I'm just going to choose, I think, this bottom left one, just the log y version. So, and we'll make some interpretation there. Choose the best scale for the linear relationship and explain why. Okay, so we're going to choose log y because the sig smoked became slightly left skewed, which is better than the extreme right skewness from before. And there was no need for an age transformation. That's pretty good. All right, does your relationship benefit from a log transformation? I would say a little bit, since the degree of skewness around the regression line, I'll say vertically around, was reduced with the transformation, with the log y transformation. That's it. Knit it, review it, and see if you're happy. All right, so I want to do one more thing in this video, but that's basically the end of the assignment. We did have this other variable, personal income, and we could relate personal income to either age or cigarettes smoked. And I'm interested to relate it to cigarettes smoked. So I'm going to do a separate set of plots. I'm going to copy all the plotting code, and I'm going to put it below. And I do not encourage you to do this. Okay, but this is just sort of exploratory for me, and to show what it would be like to try it again with another variable. So what I'm going to do is, so first we want to think about what relationship do we want to model. Do we want to think about income affecting how much you smoke, or how much you smoke affecting your income? Call in at 555-1212. So I think what I'm going to do is treat income as the independent X variable and have that affect how much you smoke. Okay. The idea here being that I think that people who are more affluent tend to smoke less, and people who are less affluent smoke more. So I want to see if there's a negative relationship there. So what I'm going to do is I'm going to search Control F. Let me do this sort of without any shortcuts. But I press Control F. You would do Edit, Find, and Replace. I guess it's just Find. Okay, and I'm going to search for age. And then I'm going to replace age with income personal. This is the current one that's highlighted. So if I click replace, it's going to replace age with personal income, and then it's going to jump to the next one. And I'm going to make this window bigger. You can see that there's another age down here that has a little gray box around it. So it's found this age as well, but the one that's with a gray background is the current one that's selected. So I'm going to replace it. you saw how it updated that value here, and then it went over here to this x. Okay, so I'm going to replace it there, and now it's to this one. And I'm going to be very careful just to stay in this area, because when I'm done with this next age, well, I think there's one more below, but then it's going to jump. You can see what line number I'm on, 1500. Okay, it jumped down. Total cigarettes versus age, 1530, replace. Now it jumped up to line 12. Okay, so I just did one at a time. If you click all, it's going to replace all instances of age with personal income, and that's clearly not what we want to do. Something else I should have done is I should have selected match case, which would have only looked for age with a capital A and not found this word paged. Okay. Anyway, so that's fine to replace. Let's go to, can I go to the previous one like this? Hold on. Previous wrapped around, and but age is not what I'm looking for anymore. Okay, here I am. So income personal. Income personal. Okay, I don't really care about these titles. You know what? Let's do this. I care enough to... Okay, income personal. Let's change that to personal income in the title. And we will replace... and then do next. I don't want to change the variable name. I'm just changing the labels. Next. There's the label. Replace that one. Next. Okay, looks like you can do Control-Shift-J to replace. And then to do next, you could do F3. Smoked versus personal income. Okay, let's search for the previous one. That'll wrap behind. Okay. Anyway, all that to create a new plot. That was not a lot of work. Let's just run the darn thing and see what we get. It'll create 4 plots and grid arrange them, and then I will click zoom to make it large, and we'll take a peek. This does not look the way I was expecting it to. I'm getting sort of a sneak peek in the bottom corner. All right. Wow. Okay. Well, oh, this is great. Okay. So here's personal income. Almost everyone earns very little. I mean, you know, 1e plus 0.6, that's 1 times 10 to the 6th power. Okay. So the people who right here are making $1 million a year. So I don't mean to say that you're making very little if you're making $200,000 a year. I wish. But, you know, most everyone is making between 0 and probably like $40,000 or $50,000 a year. Probably most people are in that range. Anyway, look what happens when you take the log of the income. It becomes almost symmetric, centered at, let's see, 1 times 10 to the 4th is $10,000. This one is 1 times 10 to the 5th. That's 1 with 5 zeros. That's $100,000. So between 10,000 and 100,000, that's most everyone. Though there's quite a bit of people between 1,000 and 10,000. That's a little surprising. And then all these guys who are down at 0 are still at 0, basically. I think that when you use this function, the log, this one here, the scale x log, oops, sorry. When you use that function, if there are zeros, it still puts the zeros on the plot rather than setting them to be undefined, which is a sort of a nice property. Okay, so that's logging x made a great difference. That's great. How about logging y? So we start with this distribution. Actually, we start with this distribution, and when we logged y, you can see that the distribution of points is sort of more centered around this line, whereas where the regression line is here, we have most points down low and then a few that are up high. And if we log both of them, then we've taken this clump of points that are way down low and shifted them up. So this is actually a pretty good improvement. If this was my project, I would probably interpret this plot and say log x, log y, it made a big difference for both of them, since both personal income was right skewed and total cigarettes smoked was right skewed. They were both really right skewed, and logging both of them made a big difference. All right, good. I'm glad I followed my curiosity and checked that out. I think what I'll do in the assignment is I'll just say that here's an example where transforming both x and y with the log makes a big improvement. Okay, so there's that example for you. I think that's everything for this assignment. I hope you find some nice relationships. By the way, as a closing comment, it is not, if logarithms make things worse, you should just say that. There's no expectation in this assignment that you're going to take the logarithm and that's going to make an improvement. If your data are naturally wonderful, the way the plot that has height versus weight, where is that one? Bivariate, regression, scatter plot, right? So here's height versus weight. You're probably not going to improve this with the log transformation. So you just say, log didn't, oh, I tried to zoom in and then it ruined everything. Okay, anyway, the point being is that if it doesn't make an improvement, you just say log made it worse. Typically, it'll make it worse by starting with a fairly symmetric distribution and making it very left skewed. All right, so this is finishing up. So now that I've got all these plots where I'm plotting all these scatter plot matrices or scatter plots, I've got 8 of them, each of them with 43,000 points, and I had another one before. I may want to comment one of these out eventually because it's taking a very long time to plot and my computer fan is really churning. All right, that is the end of this video. Hope you find some nice relationships with your data. I'm just taking a moment and to look at these plots. Jumping all around, I hate that. Okay, use the table of contents to your advantage. 12. How come I click on 12 and it doesn't? Let me refresh this window. Okay, we'll plot. There we go. Now that's jumping correctly. Okay, that's the one we talked about before, and this is the one that we just did. Very good. All right. Bye-bye.